All right, here we go. Review from last year.
Oh.
Nice job, Emma. Daniel. All right. So, um, difference between electric field and magnetic field. The the most probably quoted difference is, as of now, you can have a monopole electric charge. You can have a single proton, but you cannot have a monopole magnetic monopole. It has to be coupled with north and south. Okay.
As of now,
They're trying to find. They're trying to discover.
which is smaller and smaller. It would make
No, it's not making
So-
smaller magnets. We know that won't work.
Yeah. So it goes out of positive into negative, out of north into south.
Well, inside the magnets. Yeah.
Right. Okay. So you've got the cause of these are these magnetic crystals called domains. They each have their own magnetic orientation. And these are slightly microscopic, like 20 micrometers. This is like no, smaller than grains of sand. It's like white blood cell type. Like you can see it under a cheap microscope, like a school microscope.
Yeah, I bet I still won't be
You
able
can
to
see a lot of things under a
Okay. So the more that those domains are arranged, the stronger the magnetic field, and the stronger the magnet you get. The magnetic South Pole is at the geographic North Pole. Remember that whole conundrum? Okay.
Why is that one again?
The reason why that happened was because when magnets were discovered, they used them as compasses, and they put them on ships, and you could sail it. They'd always point geographically north. They didn't realize that a compass was a magnet. They just knew it pointed north. No one ever decided, hey, what happens when you put two compasses together? Like, why would I need that? I already have one for my ship. And so we would call the part that pointed north the north-seeking pole. If you're a salesperson, you're like, hey, this points towards north. This is the north-seeking. This is the North Pole of this thing, North Pole. And so that's where the convention came from, North Pole, South Pole. But we found later that when you take two compasses, which are just floating magnets, opposite poles attract. So I guess the geographic North Pole where Santa Claus lives, North Star, is the magnetic South Pole. Same.
Never mind, keep going.
Okay.
I had two things, but I forget both of them.
Okay. All right. So first right-hand rule. You have moving charged particles create a magnetic field. Stick your thumb in the direction of current. Fingers wrap around in the direction of magnetic field. Okay.
Oh, I don't like these. Remember, it's an arrow.
Correct answer is out of the page, circle with the dot. There's the arrow coming at you. Feathers of the arrow going away from you. Another way you can think of it is you're spinning the tennis ball on a string and you let go at point P. Which way does the tennis ball fly? Okay. Very good. So these. This is the wire. Current. You're looking down the shaft of it.
Is P the midpoint? points?
Yes.
We're assuming.
Okay.
No, just talk to us. Oh, okay. It's just a walking.
Oh boy.
Tell your neighbor.
When do you get Jimmy Young, Brad? Whatever.
I got A.
C.
What?
Because when you do the thing.
This guy creates a magnetic field going this way from the orange. This one creates a magnetic field
Wait, is it not like this?
going this way from the blue.
Why is it not that way?
Use your right hand.
Oh, you do the right hand on P?
Nope.
No, I thought.
Oh, I was thinking this. That's a lot.
Good?
Yeah. What in the heck?
You guys saw this last year. Yeah.
Oh, I guess I understand this. This makes more sense. Oh yeah.
Yes, Isaac.
The solenoid.
Does the current intersect there at that intersection point? So do
No.
the wires intersect, or is that bridge? Thank you.
You're welcome.
Can you just text me, I need to stop fighting. Legend. I assume so. I'll ask for it.
Put it in the Discord. I didn't get to see that.
Well, you were late. You didn't even watch the fight.
Well, no, because there was like 30 kids and no one moved.
They were fighting.
Yeah, but like.
All credit.
Oh, we gotta get out of the way.
I don't know there's a fight until I'm told in the next class period.
Yeah.
It's alright.
As close as I'm going. I feel like I have to see one before I drive.
I've witnessed a single fight.
You are the instigator.
Yeah.
The only one I've seen is Carly.
Let's go.
You guys seen that video?
Oh wait, is there a video?
Oh, it's really grainy.
Where are they?
Oh man.
Let me see.
Smiley, I have an answer to the question.
Okay, tell your neighbor the answer to this question. Good, I like it. E sounds good to me.
Decided to turn around.
I feel like it gets to stop.
Oh yeah. This is such a bad video.
You do make a rap.
I do look like a therapist. Like, hey man, don't do that. Oh. Yeah, show for that.
You put in the distance.
Let's go. Hey, so
Right,
right,
recording question.
It is. Okay, this section is talking about this right here. The part of the loop that's closest to you.
What did that mean?
Yeah, it didn't send. I don't know why.
No, that's not what I mean.
It just says here.
Yeah, I tried to send it.
If you try to snip this way through like the.
Smiley, you gotta love number here.
It doesn't work.
I'll airdrop.
How do you maintain current through such a wire, though?
Superconductor.
Okay.
So yeah, that should be.
That would work.
Would.
Smiley's
Otherwise,
finally
the
pricing
resistance of the
for
wire is
these
going
questions.
Otherwise, the wire's going to heat up so quickly that its resistance becomes non-negligible, and then you have to, yeah.
Okay.
Why is it so right to the left?
Isaac,
it's at absolute zero.
Just
Oh.
Not the electrons.
Your electrons.
okay. Correct answer is
They slow down the more.
correct answer is B. Okay. Ready? This one's gonna be good. B. You can either do it one of two ways. The traditional right hand rule.
Oh, yeah, you got the other thing.
By looking at this part that's closest to you, grabbing it with the field going down behind it, because that's the part that's closest to you. Your thumb is going to the left. Or you can do the alternative right hand rule. Stick your fingers in the direction of the magnetic field, and the current goes in the direction of your fingers around the loop. Okay. Oh, there it is. Alternative right-hand rule.
Not airdropping it to everyone here.
It's up to me. Airdrop it to most of the people.
Don't airdrop it to me.
765. No, dude. 738.6.
Dude, I want to see.
Smile, you have to be a little bit.
Open your airdrop.
You can just connect to this and we can play it on the street.
Yeah.
Smiley, that would knock it all out. That would knock it all out. No one knew
Yeah,
what to talk about
like,
anymore.
the rest of guys.
Come on,
Such a
Smiley.
bad
Thank you, Cora.
Wait, hold up, but like,
You sent it?
I don't know which end of the compass goes.
The painted is the North Pole.
That's not helpful for me.
I don't know.
The darker one.
That's not helpful for me either, but for different reasons. Wait, no, it goes.
I think.
Yeah.
It goes from north to south.
I think one of them's
So-
darker.
You can't tell when it's white versus red,
It goes out.
and it's got to be the brighter one's white.
Okay, I think I can tell
Um,
kind
Well, it's gotta be that one.
is.
Current going this way. So current sort of magnetic field going down.
Wait, I have the other way.
Painted. That's a painted, yeah.
Oh, send that video. But I did it on purpose. Like, I thought it'd be funny if I rode my bike into a sandcastle.
Sure, Adam.
But I have a video.
Where?
So, some random person.
That's okay.
That's car.
Yeah.
Wait, where were you?
South Quadrant.
Is that how you got your finger too?
Were they watching you? Like,
It was a regular
castle? Okay.
Yeah,
So they weren't, okay.
Wait, what happened?
It'd be so funny if they were just watching you, like, in their sandcastle.
I went into it really fast. Oh, it actually it's that.
Yeah.
Oh, you
Did
just
you land in the sand?
It's 7.5
Yeah.
megabytes heavily.
I guess it makes sense with friction. But like it was like the hard sand, like as the tide going down. Like,
Yeah,
the
but then
stuff
it'll be
was-
the
yeah.
other
Okay, correct answer is
Smiley, we got it for you.
awesome. Yeah.
Aaron just texted me. Emma, did you see the fight, bro?
Oh!
Oh my god.
It was intense.
Brad's getting them.
America's
It was
man.
so
Brad
bad.
Pitt and everything.
Oh yeah.
It was such a feeble attempt.
Guys,
That was
get up and walk through it.
That's the real problem. Was that it was just like I didn't really try that hard.
No, look at Trey in the background. Look at Trey in the background. Brad, what were you expecting to do?
I was hoping to pull one off of the other, and then I got into it, and I was like, I don't want to like break your arm doing this, and I don't want to break my arm doing this, and I was like, okay, well,
That's why you just leave
this
it
ain't
alone.
really gonna happen.
That's why you just leave it alone. Once it dies, they die. Once it dies, it surprises.
Okay, I'm done watching it.
All
We're
right.
good now, Smiley.
Ready?
We're good now.
Clear.
I got my answer. And we'll watch it again.
Here we go.
Should feel more.
So it goes around like that. Magnetic field's going up. C.
Wait. Why
So
is
the red is the north part?
Which way? How are
Painted.
we supposed to figure out which way the current's going? Because
Positive has the. Yeah, I should have told you that.
one's faded and one's on top of each other?
This is positive, negative.
okay. Okay, well then you're right. Okay.
Okay.
Current's going
It's going out of positive into negative. Going around like that. So the field's going up through the coil.
So how do we know that current's traveling in this direction?
Goes out of positive into negative.
Smiling.
Wait, so what's the answer?
How powerful is the Earth's magnetic field compared to something like this?
It's not.
Not super.
It's not.
Going this
Just enough to deflect us.
Wait, so it's like based on how it's drawn because.
Mhm.
Okay.
Just like this one, gonna be based on how it's drawn.
Okay. I blame it on my bias. I'm just surprised.
What is that group chat talking about? No,
And it
wasn't.
It's better than what I did.
Oh, yeah, but no, like nothing
Morally
was
maybe, but on video it doesn't look like it.
But I wasn't there for that.
But morally is what you should
I
do.
saw
Morally
they
is
were
what I
shooting
care
each other,
about.
and I saw they shoot back to
There was a brief middle section.
Okay, here we go. Let's power this through here.
Okay, yes, I'm trying.
Uh-huh.
Hey, now I am. I promise.
Oh no, Smiley, my mom just texted me.
she should be proud.
What happened? Question mark. The fight? 2 question marks, and that's bad. Yeah, I will.
Yeah.
That's debatable.
If Brad's not here tomorrow, we know what happened. Everyone else in that video did not try out.
No, that's true. But
They were bystanders.
No, they were
Didn't award that.
instigators. Fight!
That guy was he like throw elbows?
Yeah, that is true. That is also true.
That actually was Brad.
What?
Yeah, that was me, and then just so I could say I did the moral thing.
Like gladiators.
Bro, we don't have a convocation.
Fight Club.
All
Alright,
I'm not gonna get a
tell your neighbor.
I didn't do anything.
Actually, we're not going to tell your neighbor. I'm just going to tell you the answer.
Hey.
So you want this to be south. So you want the magnetic field lines to go in this way. So you want the currents going this. So the currents going this way, to the left, to the right. So B.
Oh, I'm using my left hand, that's why it's wrong. Okay.
Okay.
Oh. Wait, will you wait for one more second?
Mm-hmm.
Well, you want
Okay.
to look at the top of the magnet. Like right here where you like.
Oh, to make it repellent. Okay.
Good with that?
Yes.
Look,
Now I'm like,
go back to the last
yeah, okay, cool. Put that on there.
one, which is the opposite of that.
Goes. Current's going this way. Yep.
Oh wait, no.
Okay. So electromagnet. This technically is an electromagnet, but it's really strengthened when you stick an iron core in it. Okay.
Oh yeah, because you can polarize stuff.
Yep. Okay. So second right hand rule.
This one.
Fingers are still your magnetic field. Thumb is for a particle, the velocity. For current, it's for a wire with current, it's the current. Okay. And then positive. Palm pushes positive things. If it's negatively charged.
Then you
Okay.
use the left hand rule.
Nope. Well, back of the hand. You can be a conventionalist or a realist. Conventionalist follows Ben Franklin, thinking that positive things are flowing in the direction of current, which I would recommend because it's just easier to deal with. But if you're like, you will see something where Ben Franklin's convention falls apart. One example. There's the only example I'm aware of. But it won't happen in the review. Correct answer is C. Going down. Here's your hand. Thumb goes in. velocity.
Force. I'm not
Your
sure.
palm is your force.
Yeah, okay.
Fingers are going down.
Wait, hang on. Say that. Go.
Yeah, go down.
Thumb's going in. Velocity.
Oh, that's the force. I'm sorry, I misread that. Yeah.
Okay.
Oh, he's pushing negative. Oh, wait.
Just move your body. That's a lot simpler than twisting your arm.
It's not too bad.
Correct answer is D.
D for catapult.
Okay. You can hold your hand like this, or you can hold your hand like this. Back of the hand goes down. It's negatively charged.
Oh, slide.
Correct answer is no force. There has to be a component that is perpendicular. Component of velocity needs to be perpendicular to the magnetic field.
Or a component of the magnetic field could be perpendicular to velocity.
This is true. Okay. So, oh, I about used the wrong one. So, here you're using magnetic force is equal to magnetic field times the charge. I like writing it like this. A lot of textbooks like writing it like this. That's all fine and dandy until they give you something where, oops, 50. Sorry. Until they give you something like that. And then you're like, oh, sine of 50. You don't. You need to find the component of the velocity that is perpendicular to the magnetic field, or the component of the magnetic field is perpendicular to the velocity. Okay. Okay. With this one, here's what I'm trying to get at. Here's the point. You do not stick your thumb in this direction. You stick your thumb in the direction of the component that is perpendicular to the magnetic field. Okay?
I mean, even if you put your thumb like this, it still works.
So, into the page. Back of the hand, negatively charged. Okay? So, if we shoot a proton through here, experiences a force up. As time goes on, it's now moving this way because of inertia. Still experiences a force this way, moving this way. And so if there's magnetic field all over here, this continues and goes in a circle. Because the magnetic force plays the role of centripetal force, always pointing perpendicular to the direction of motion. Does no work. Okay, because it's always perpendicular to the direction of motion. Plays the role of centripetal force. If it's centripetal. Mm-hmm.
Oh, okay.
Yep.
So initially the force up, and then slowly do it. I did like a solo.
Okay. So applications of this, you get your northern lights. You also get the result of particle accelerators, like the crash of that. So you can see what parts of the wreckage are positively charged and what's are negatively charged based on the spin. This is a very popular thing in introductory physics, is a velocity selector. So you have a you shoot a charged particle through this region that has both an electric field and a magnetic field. Okay. And you want to do it so that these two forces cancel each other out. So the electric force is just based upon the charge and how strong the electric field is. The magnetic force is based upon the strength of the magnetic field, how fast that thing's going, and the charge. Mm-hmm. So here, the charge cancels out, so you end up with that expression. I wouldn't worry about memorizing that, though. If they give that to you, you're going to have to derive that. Okay. Tell your neighbor.
I'm gonna say C because it's not moving. If it's going through a magnetic field, it's not movement. It's going through an electric field. Yeah, the velocity is going straight.
Go up
Oh, the velocity, not the
like
trajectory.
this, right? So
Oh.
it's this
No, B's going out of the A. Right?
If the trajectory exists, it's probably awesome.
No, B's going. Wait, no.
way. Yeah, that's okay.
Plus the trajectory of my eraser.
Oh,
B,
shit.
F.
Oh, that's really cool.
Oh,
Actually.
shoot.
Correct answer is D. If you do it for negative, it still works out.
How do you do it with the electric field?
Electric field, so the force from the electric field, if it's positive, is the same direction as the electric field. If it's negatively charged, it goes in the opposite direction as the electric field.
Oh, because it depends on the charge of the particle. If you're given the charge of the particle, then it has to be one of them. But since it's just you don't know what it is, then
Right. It doesn't, it can't. Yeah. So correct answer is D, out of the page. The force has to be, the electric force is going down, so magnetic force has to go up. It's going to the right, negatively charged, back of the hand, out of the page. Okay, so the charge doesn't matter here, but it does matter once you get into a place where it's just a magnetic field. Okay, so if it was one charge, it'd go the other way, like go this way. If it was another charge, it'd go the other way. So this is known as a mass spectrometer. And you can, depending on how tight the radius is dependent upon how massive it is and how fast it's going and the charge of it. It's a lot of different things. Okay. But very popular for response questions because it's a series of questions that are all tied around this setup. Okay. So these are the types you would see in a university, like just for educational sake. They make them glowing. So you're like, oh, cool. But when you get in the lab, they look like this. And so, and here you have your here's your selector right here, and this is your magnetic field. And you're trying to your targets here. So you mess with it to get things hitting it. Correct answer is B. So you've got magnetic forces playing the role of centripetal force. Got mass times speed squared over the radius is equal to magnetic field times charge times the velocity perpendicular. So same mass. So the bigger the charge, the stronger the force, and the quicker it turns. It's able to turn. Smaller the radius. And so get these cyclotrons, which they just shoot the charge through here and it does a whole circle. I want to say that's more of like, I'm not sure where they use that in industry. It's a cool physics lab at the university level. Nice. Gonna make it, kids. Gonna get through it.
How many more slots?
3. Correct answer is F. Okay. Okay, so this is Ben Franklin followers. Okay, if you're a realist, okay, then you have to say electrons are going in the opposite direction of current and then negatively charged. But Ben Franklin followers.
What's the answer? The answer to that?
Yes. Okay.
Oh, this crap. This is actually some cool stuff.
Correct answer is
C.
good job, C. No force. These are parallel. Thumb's going up, fingers going to the right. Goes into the page, out of the page. Gonna spin like that. Talk to your neighbor, talk him through it.
Too large current all attract each other.
Because it's where we care about the magnetic field. So we use it, right? And then you say, okay. Rest of the magnetic field going this way.
Okay. Correct answer is A. This one creates a magnetic field coming out in this vicinity. This one is in this magnetic field. Thumb is the direction of I1. This is magnetic field from I2 and force down. Okay. You could go through the same procedure and get that I2 is going to be forced up, but also Newton's third law. You can use that as a shortcut.
Yeah.
Oh, yeah, that's true.
Yeah. Last one.
Hold up. Do this.
You can do it. We're good. Tell your neighbor. Talk them through it.
And Tim, you are correct in saying that the directions of the force are opposite, right? The only thing that's different is that the magnetic field at the top of the roof is getting stronger because oh my goodness, bro. That's okay. That makes a lot of sense now. You got the right theory. We haven't talked about it.
Correct answer is?
C.
Correct answer is C. Okay, so this force is stronger than this force because this is closer to this magnetic, closer to the wire, which has a stronger magnetic field. These, this force is going the page. This force is going. This force gets smaller and smaller, but because of symmetry, these forces cancel out. But theoretically, you could figure this, like, what's the net force on this side with calculus?
I can guarantee you that's going to be some sort of question.
Okay.
It doesn't matter if they cancel out, right?
Yeah, they cancel out here.
Unless you're thinking about like ripping the wire.
Right.
Oh, it reminds me that
Okay. So you got reading due tomorrow. Reading quiz. Oh yeah. How many people are on robotics?
Sign me up. I love robots.
So we'll have a mastering due on Wednesday. Like not like this Wednesday, but a week from Wednesday.
When will our test be? Like the end of the month? I thought we should have 2 tests.
They'll be close.
Like how close? Like one over. What are we gonna learn in between?
Nothing.
We're just having two
It's just a phone, right?
Yeah. I mean, we'll do like a week of review or something.
So the test will be over everything?
Yeah.
This pretzel.
Not like everything this semester.
Okay, so it's not a combined. I might not do so well on that test.
Oh, you better. Maybe I should make it like a.
No. Well, I mean, I can do well on a pure mechanics test or a pure E&M test. But a test that's a mix of
No, it'd be.
then
It'd be.
I'd have to switch between the two.
No, I'm giving you the same experience you're gonna have on the test.
Okay. Yeah, I remember that. I remember 2 AP exams that we take.
Yep.
One mechanics, one E&M.
So.
I can do that. I can't.
So just letting you know, for those people who are like scheduled people, the AP exam is on Tuesday, May 9th, and you are going to be staying after school to finish it.
In addition to your AP leg exam.
In addition to your AP English.
Yes, he doesn't have to take that. Let's go.
Me.
How many people have the English? Rough.
How would they do that, by the way? Like, don't they usually, like, they know physics is hard, they put all the stupid APs with it? Like, they definitely do that.
Well, most people don't take leg and light in the same year.
I don't think they're
It's a pretty
organizations
lot of essays.
that are having stupid APs. Well, there definitely are stupid AP like macroeconomics. I'm not denying it, but what the hell is that?
There's some
Yeah,
vocabulary.
like oh, their own like
Daniel, do you not know what macroeconomics is?
something stupid
Yeah,
probably.
it's like